Alright, so today we're going to be looking at free response question 3 from the 2021 AP Calculus BC exam. So the question reads, a company designs spinning toys using their family of functions y equals cx square root of 4 minus x squared, where c is a positive constant. The figure above shows a region of the first quadrant bounded by the x-axis in the graph of the function for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. Part A reads, find the area of the region in the first quadrant bounded by the x-axis in the graph of the function for c equals 6. So the first thing we need to do is find the x-intercepts for the function. So in order to do that, we need to take our function, which is y equals cx squared root of 4 minus x squared, and set it equal to 0. And we can also substitute 6 in for c. So it's going to be c0 equals 6x 4 minus x squared. And if you simplify that and solve for x, that is going to leave you with x equals plus or minus 2. And so we are in the first quadrant, which means that we are looking at positive x and y values, so we can get rid of the negative 2 here, and we'll be integrating from 0 to positive 2. So a equals, we can go from 0 to 2 of our function, which is 6x 4 minus x squared dx, right? And to integrate this, we are going to be using u substitution, and we're going to set u equal to 4 minus x squared, and I'll leave du to be negative 2x. So then we're going to work that into our equation, right? 2x minus x squared dx. Then we're going to substitute u in. Then take the antiderivative, and the 3's will cancel, and that'll leave us with negative 2, and then we're going to substitute 4 minus x squared back in for u. And then we're just going to integrate, so that's going to leave us with so that's going to leave us with 2 times 8, which is equal to 16. And our area is going to be equal to a equals to 16 inches squared. So now if we take a look at part B, it says it is known that for our function dy of dx, the derivative of our function, equals c over c times 4 minus 2x squared over the square root of 4 minus x squared for a particular spinning toy. The radius of the largest cross-section circular slice is 1.2 inches. What is the value of c for the spinning toy? So the first thing we need to do is find the x value for the for when the largest cross section, which is what I just drew where that 1.2 is. We need to find this x value right here. In order to do that, we need to take the derivative they give us, which is, and set it equal to 0. And so to find when the derivative dy over dx equals 0, we need to make the numerator 0. And in order to do that, we need to find what value of x will make the numerator 0. So if we look at 4 minus 2x squared right here, what x value make that 0? If we look at it, the x equals square root of 2 will make the numerator 0 and make the derivative 0, which tells us that there's a critical point at square root of 2, and since we're looking at the graph, we know that it is a local maximum, and that is the x value where we have the largest radius of a cross section. So now using x equals square root of 2 and y equals 1.2, we're going to plug those into our original equation, which is y equals cx square root of 4 minus x squared, and then solve for c. So 1.2 equals c times the square root of 2, 4 minus square root of 2 squared, all over into the radical. And if we solve for c, that's going to leave us with 1.2 over 2, or 0.6. Now if we took a look at part C, which asks us for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for the spinning toy? So if we look back at the beginning of the question, it says that the solid is generated when the region is revolved around the x-axis, right? So that is going to give us a shape that kind of looks like this, right, with our cross sections there. And so that means that we're going to be integrating from over the x-axis this way. And each cross section is going to be a circle. And so the area of a circle equals pi r squared. So our volume is going to be equal to pi. Limits of integration are 0 and 2, as we found. Our original equation, right, which will give us our r, which is cx root of 4 minus x squared, right, because our r squared dx. And that is going to be equal to 2 pi as given in part C. So then we're going to use all this and solve for C. I'm going to show you how to do it. So the first thing we're going to do is we are going to distribute this square symbol over our function, and that's going to give us 4 minus x squared. And since C is a constant, we can pull that out front, and the 2 pi and the pi will cancel, right? We divide from both sides, so it's going to leave us with c squared, x squared, and then we're going to multiply that by the x squared and distribute. So there's 4x squared minus x to the 4th dx equals 2. And then if we work and find the antiderivative of this right here, that'll give us x to the 3rd, 4x to the 3rd over 3 minus x to the 5th over 5, right? And then that's all times c squared. And we're going to integrate that from 0 to 2. That equals 2, right? So that's going to leave us with c squared times 32 over 3 minus 32 over 5. And if we simplify that, will leave us with 64 over 15. And we're solving for c, so it's going to be c squared equals 30 over 64. And then if we square root both sides, c equals the square root of 30 over 8. And that is our answer.